This is Chapter 1, Question 2 of the Regression Models book, Solutions. So this question says, reconsider the previous question. Suppose that weights were given 2, 2, 1, 1, so that we wanted to minimize, and let me write out this equation. Here it's written out in our code, but what we want to minimize is summation of the weights times xi minus mu quantity squared. Well, one way to think about this, I could write this out. I could write this out as 2 times 0.725 minus mu squared plus 2 times 0.429 minus mu squared plus negative 0.372 minus mu squared plus 0.863 minus mu squared, which is exactly the same thing as writing these two out twice. 0.725 minus mu squared plus 0.725 minus mu squared plus, and so on. Okay? And we know that's simply then the least squares equation, the least squares equation with only a mean, for a data set that is just like this data set, only it has 2 of these in it and 2 of those in it. Okay, so it'd be just like as if we added. So one thing you could do to answer this question is just recreate this vector with 2 points in it, with those 2 points repeated twice. But let's look at what that would be. The answer would be 0.725 plus 0.725, because remember the solution is the arithmetic mean. So it would just be the arithmetic mean of the vector with those 2 data points repeated twice, plus 0.429 plus negative 0.372 plus 0.863. All over now 1, 2, oh, and I forgot the whole point, this extra 0.429 there. Let me see if I can squeeze it in. 0.429 plus 0.429, okay? Plus, okay. So that's 1, 2, 3, 4, 5, 6 data points. Notice the original data set only had 1, 2, 3, 4 data points, but we've repeated those twice. So that's 6 divided by 6. Well, you can look at this, and that's just 2 times 0.725 plus 2 times 0.429 minus plus 1 times negative 0.372 plus 1 times 0.863. Okay? And the denominator, 6, is just 2 plus 2 plus 1 plus 1. So now we can give you a general rule that if you have weights, and they don't have to be integers, if you have weights, even non-integer weights, the solution to this least squares equation is going to work out to be summation wi times my data divided by summation wi. Okay? And again, this time I won't do the R code, because I think just taking this and doing, well, actually let's do it. So let me copy the data set. So there's my data set, and then let me get to R. There's my data set, and then here's my weights. And so my solution is going to be sum x times w divided by sum w. Okay? And that would be the least squares solution.